Hi there, my name is Cody Mack and welcome to another episode of the 5 Things You Need to Know. And today we're going to talk about why your plumbing pressure creeps up. So most people relish in the great pressure that comes from their plumbing systems in their homes. For me, it means that I can spray my children with the hose from an even safer distance. But if it's too high, it could also mean putting your plumbing fixtures and your home in danger. Some may experience greatly fluctuating pressures in their system, so let's talk about why. The first thing you need to think about is, where does your water actually come from? Most of us receive our water from a municipal water supply or a private well. If you get your water from your municipality, where do they get it from? And how does it get to your home or business? There's a good chance that it comes from a water tower or a location with a much higher elevation compared to those that actually are going to use it. This elevation, coupled with gravity, will increase the water pressure to the tune of 0.433 psi per foot. Now that might not seem like a lot, but if there are hundreds of feet of difference between the source and the user, it can add up really quickly. Another thing to consider is the dynamic nature of a municipal water service. With a potential for thousands of users, the pressure can actually, it can and will change with demands from the network. More demand will cause that pressure to fall off, but if you were to look at the incoming pressure in the middle of the night, it will likely be much higher. Okay. This is where a pressure reducing valve will come in handy to provide stable pressures to your fixtures. Most plumbing codes adhere to a maximum pressure of 80 psi. Anything higher can potentially damage fixtures. The next thing you should know is that there are going to be consequences for a dirty pressure reducing valve. Okay, so we talked about this before. A problem that everybody's going to deal with is going to be dirt. Your pressure reducing valve is not impervious to dirt, and despite your best efforts to control pressure by installing one, it won't work very well if it's dirty. Most pressure reducing valves are going to have a screen or a filter around that cartridge assembly to protect the cartridge, and this can actually become plugged. Plugged screens mean that less than normal water flow is going to occur, or maybe even no flow at all. When small enough, that dirt and debris can actually sneak past the screen and get into the sealing components. Now, if dirt gets in the way of sealing, water can actually sneak past it. At this point, it's going to take more pressure downstream to close off the valve, and in some cases, it might not even close off at all. So during normal use throughout the day, you might not notice that this valve is not maintaining the set pressure, but during long periods of inactivity, your system pressure will have time to creep up even more. This is when you may run into a leaking pressure relief valve on your water heater. Pressure relief valves are a safety device to basically make sure that your water heater doesn't go kaboom. One last recommendation here is that I would recommend a pressure gauge somewhere downstream of your pressure reducing valve. Some pressure reducing valves even offer this as an option at the outlet. This is a great way to monitor that pressure in your system to make sure that your pressure reducing valves are working properly. The next thing you're going to want to think about is your expansion tanks, and if they are undersized and or failed. Now, in many domestic water systems with a water heater, an expansion tank is going to be present. As the water is heated, it's going to expand and that pressure is going to increase. Expansion tanks are designed to soak up this increase in pressure while maintaining a consistent static pressure in your domestic water system. An expansion tank is especially important if you have a pressure reducing valve or backflow preventer installed as the supply enters your home. Either of these devices will have the ability to isolate your plumbing from the network of piping going throughout your neighborhood. So you pair this with a situation when there is no demand from your fixtures and you have a sealed up system with nowhere for this increase in pressure to go without an expansion tank. If this expansion tank is not sized correctly or it has failed, it will lead to very erratic pressure changes in your system and likely a leaking pressure relief valve on your water heater, as mentioned before. Now, we talked about some other problems that you can see in your system, and we talked about some of the things that you can have problems with pressure reducing valves, but let's talk about exactly what a pressure reducing valve does. A PRV is going to be a device which, when installed on a water system, is going to reduce and stabilize the pressure of the water entering from the water supply main. This pressure in general is typically too high and variable for domestic systems to operate correctly. Pressure reducing valves function through the use of a calibrated spring-loaded valve. When a fixture is opened, the force of the spring becomes greater than that of the diaphragm. The shuttle moves downward, opening up the valve to the flow, allowing the flow of water. Now, when the fixture closes, the pressure downstream is going to rise and it's going to push that diaphragm back upwards, and as a result, that shuttle is going to close that valve to the flow of water and it's going to maintain a set system pressure. What if there is a way to install a pressure reducing valve that would allow backwards flow to relieve excess pressure in your system back to the water supply network? There are some circumstances where you'll need a pressure reducing valve but may not be required to have a backflow prevention device. In this instance, you may think a PRV with a bypass valve is going to be a good option. Maybe it might even allow you to skip that expansion tank. Some pressure reducing valves still offer this, but in most cases it's not a viable option. Beyond the fact that the local water utility does not want the water back after it's entered your home or business, there's going to be another hurdle. A bypass valve to allow backward flow through your PRV will only open and or work if the inlet pressure is less than the outlet pressure. If you have a pressure reducing valve installed, it's because you have high or erratic pressures entering your building, so it's going to be pretty unlikely that the bypass valve will ever even open. Beyond this, most water heater pressure relief valves are going to be set to 150 psi. If your inlet pressure is going to be greater than this, you won't be able to relieve the pressure in your system before your relief valve opens on your water heater and makes a big mess on the floor. So let's summarize the 5 things that you need to know here. The first is going to be that you're going to probably have an erratic source, and if you've got pressure fluctuations or erratic pressure in your home, you got to remember where that water comes from and that a PRV might be necessary. Now if you do have a PRV, number 2 is going to be for you because dirt and debris can cause that PRV to not work properly. It's going to fluctuate up and down, it's going to leak by and things like that. Number 3 is that you need to make sure those expansion tanks are sized appropriately and set appropriately and make sure that they have not failed. Number 4 is going to be that you want to make sure that you understand how a PRV works and you don't want to abuse it. Okay, it's going to have some limitations and you want to make sure to abide by those. Number 5, bypasses are not a good idea. Like I mentioned before, water utilities don't want that water back after it's entered your home, so you make sure to keep it. Thanks for joining us on another episode of the 5 Things You Need to Know. Again, my name is Cody Mack and we hope you tune in for the next one.